Okay, so let's talk a little bit about where we see recursive sequences or recursive work being done. Typically, recursion works really well if you have a problem that can be broken into pieces where the pieces kind of look a lot like the original problem. So if I needed to sort all of your homework by first name in order to hand it back, usually what I do is I sort it into piles like first names A through E, then F through J, and so on. And then once I've sorted into kind of those smaller piles, I sort each pile alphabetically and then put them all back together. Okay. Recursion also shows up in computer programming, so like collision detection and game development. Some compilers are recursively defined. Um, it's also used if you're trying to work backwards for something. So, like finding patient zero, and you have an infected group, so you're working backwards to find out where that started at. So, any of those kinds of things would kind of fall into that area of recursion. All right, so let's try a couple more problems here. So number 8 is a sub n. This one actually has two starting values. So we have 1/2 of the quantity a sub n minus 1 plus a sub n minus 2. So we're going to add the previous two terms and then multiply by 1/2. So when n is equal to 2, when n is equal to 3, we're going to have a3 is going to be 1/2 of a2 plus a1. So that gives me 1/2 of 0 plus 1, which is 1/2. All right, to get a4, that's going to happen when n is equal to 4. So a4 will be 1/2 of a3 plus a2, which is going to be 1/2. So a3 is 1/2 and a2 is 1. Okay, so 1/2 of 1/2 plus 1, which is going to give me 3/4. Okay, and then we'll do one more. So when n is equal to 5, that'll give me a5. And a5 is going to be 1/2 of a4 plus a3. So 1/2 of 3/4 plus 1/2, which if I did my math right, gives me 5/8 as an answer. So that kind of gives me the next three terms in that sequence. All right, and then number 9, a sub n is going to be equal to n times a sub n minus 1, and we get a starting value of equal to 1. So I want you to give this one a try and see how you do with it. Pause the video, come back in a couple seconds, and we'll see if we've gotten the same thing. All right, so let's see if we've gotten to the same place here. So I've been given a1 and I want to find a2. So that's going to happen when n is equal to 2. So a2 then is going to be 2 times a1. So 2 times 1, which gives me 2 total. To get a3, that's going to happen when n is equal to 3. So a3 is going to be 3 times a2, which gives me 3 times 2, so 6. And then we'll do one more. So a4 happens when n is equal to 4. So a4 is going to be equal to 4 times 6, which is 6 is our a3 term. And so that gives me 24 for my last one. Okay, I hope that's what you got, and I'll see you in the next video.